A bridge built in 1478 is still carrying traffic in France. 546 years old. Still standing. Still strong. The mortar holding those stones together has not cracked. The structure has not weakened. Engineers say it could last another 500 years. Meanwhile, the concrete highway you drove on this morning has a life expectancy of 50 years. Maybe 70 if we are lucky. It is already cracking. Already scheduled for replacement. Built with modern technology and modern materials. So how does a medieval bridge outlast everything we build today by a factor of 10? The answer is a plant. One single species mixed into the mortar. A material 3 times stronger than modern concrete. Fireproof up to temperatures that melt steel. Earthquake resistant, water resistant, and it gets harder with age instead of weaker. And it is illegal to use in construction across most of the developed world. Not because it does not work, but because the $1 trillion concrete industry wrote the building codes, and they do not profit from bridges that last 600 years. This is hempcrete, the material they erased from history. Let me show you why. Pont de Sully, France, built 1478, 546 years old. Still in use. Engineers who inspect it confirm the mortar is harder now than when it was laid. The secret? Hemp fibers mixed with lime. Abbé de Fontenay, Burgundy, built 1118, over 900 years old. The walls are solid. The structure is sound. Modern analysis found hemp lime mortar throughout. The material has petrified over centuries, becoming harder than the stone itself. Across Europe, hundreds of these structures still stand. Medieval bridges, castle walls, cathedral foundations, all built with hemp concrete, all outlasting modern buildings by centuries. Now contrast that with America. The average concrete bridge in the United States lasts 50 to 75 years. Over 40% of all U.S. bridges are structurally deficient. The Federal Highway Administration estimates it would cost $125 billion just to repair the deficient bridges. Not buildings, not dams, just bridges. Modern concrete cracks almost immediately after pouring. Water seeps in, freezes, expands. Cracks more, rebar rusts, expands, cracks more. The cycle continues until the structure fails. This is planned obsolescence. If concrete lasted 600 years, the construction industry would collapse. No rebuilding, no replacing, no recurring revenue. So we use materials designed to break. On purpose, hemp concrete does not break. Here's why. Hemp is cannabis sativa, the same plant as marijuana, but bred for fiber, not drugs. It has been used for 10,000 years for rope fabric paper and building materials. When you harvest hemp, the woody core is called hurd or shiv. Chop it into pieces, mix it with lime binder and water, pack it into forms. As it cures, a chemical reaction happens between the lime and silica in the hemp. The lime absorbs carbon dioxide from air and hardens into limestone. The hemp fibers mineralize over time, turning stone-like. The final material is petrified hemp, locked in a limestone matrix. The composite has properties modern materials cannot match. Hempcrete has tensile strength 3 times higher than standard concrete. Concrete is strong under compression, but weak under tension. That is why you need steel rebar. Hempcrete does not need rebar because hemp fibers provide natural reinforcement throughout. Hempcrete is fireproof, tested to over 1200 degrees Celsius. It does not burn. It does not release toxic fumes. Medieval castles built with it survived fires that burned for days. Wooden interiors destroyed. Walls still standing. Hempcrete is earthquake resistant. The material flexes. It absorbs seismic energy instead of shattering. Buildings made with it survived earthquakes that destroyed modern concrete structures right next to them. Hempcrete regulates humidity naturally. No mold, no mildew. Buildings require significantly less heating and cooling. And here's the most remarkable part. Hempcrete continues hardening over time. The petrification process continues for decades. A 300-year-old hempcrete wall is harder than the day it was built. Modern concrete does the opposite. Maximum strength at 28 days, then slow degradation forever. So why did we stop using it? In 1937, the United States passed the Marijuana Tax Act. The spelling with an H was deliberate, a foreign-sounding word designed to associate the plant with Mexican immigrants during the Great Depression. The campaign was led by Harry Anslinger, first commissioner of the Federal Bureau of Narcotics. It was funded by corporate interests that saw hemp as a competitive threat. William Randolph Hearst owned massive timber holdings. Hemp paper was cheaper and stronger than wood pulp paper. Hearst used his newspapers to publish racist propaganda claiming marijuana caused insanity and violence. Fabricated stories, zero science. But it worked. DuPont Chemical Company had just patented a process for making plastics and synthetic fibers from petroleum. Hemp plastics and hemp fabric were direct competitors. DuPont's financial backer was Andrew Mellon, Secretary of the Treasury. Mellon appointed his future nephew-in-law, Harry Anslinger, to lead drug enforcement. The connections are documented. The financial incentives are clear. By 1970, hemp cultivation was completely illegal in the United States under the Controlled Substances Act. Cannabis of any kind became Schedule I, same category as heroin. Farmers could not grow it, researchers could not study it, and the construction industry switched to Portland cement and steel. Both petroleum intensive, both degrade rapidly, both need replacement every few decades, both generate massive recurring revenue. Building codes around the world were updated throughout the 20th century. Standards written by industry groups dominated by concrete and steel manufacturers. And the new codes specified testing procedures that hemp materials could not meet. Not because hemp did not perform, but because the tests were designed around petroleum-based materials. You cannot get hempcrete approved under modern building codes in most jurisdictions. The framework assumes materials degrade over time. Hempcrete does not. The framework assumes you need vapor barriers. Hempcrete breathes naturally. The framework assumes materials are inert. Hempcrete is biologically active and continues changing for decades. So even in countries where hemp cultivation is legal, using it for construction is nearly impossible. But not every country banned it, and what happened in those places proves everything. France never fully criminalized industrial hemp. French farmers kept growing it for paper and textiles. French builders never stopped using hemp lime construction, especially in historical restorations. In the 1990s, French researchers deliberately revived hempcrete as a modern building material. They developed standardized mixtures, conducted scientific testing, built demonstration projects, pushed for building code changes. By 2012, France updated regulations to explicitly allow hempcrete construction. Not experimental, fully approved with published technical standards. The result? France now has over 20,000 hempcrete buildings, residential homes, schools, commercial buildings, multi-story apartments. It is mainstream. Builders are trained, suppliers exist nationwide. It is a normal construction option. And those buildings perform exactly as medieval structures predicted. Superior insulation, zero mold, excellent air quality, extremely low energy costs, structural integrity that will last centuries. The United Kingdom followed. Hemp cultivation legalized in 1993. Researchers at University of Bath studied it. Architects designed with it. Builders experimented. Today, the UK has thousands of hempcrete buildings. The Adnams Distribution Centre in Suffolk is a massive hempcrete warehouse. Uses 75% less energy than conventional warehouses. Won awards for sustainability. Ireland legalized industrial hemp in 2013. Hempcrete construction growing rapidly. The Irish government funded research programs because they recognized the carbon reduction potential. Canada never criminalized hemp as aggressively as America. Industrial hemp legal since 1998. Hempcrete buildings started appearing in early 2000s. Hundreds across Canada today, especially Quebec and British Columbia. Belgium, Netherlands, Switzerland, Germany, Italy, all have growing hempcrete industries, all updated codes or created pathways for alternative materials, all building structures that will outlast anything America built in 50 years. And in every country, the same thing happens. Once builders and homeowners experience hempcrete, they do not go back. It works better. Costs less over lifetime, creates healthier environments, does not need replacement in 50 years. But in the United States, it remains effectively illegal for load-bearing construction in most jurisdictions. The 2018 Farm Bill federally legalized industrial hemp cultivation. Massive step forward. But legalized cultivation does not mean legalized construction. Building codes are controlled by the International Code Council. The ICC is heavily influenced by industries that profit from conventional materials, and those industries do not want hempcrete to succeed. Let me show you the numbers that explain everything. Global concrete market, $600 billion per year. Global steel market, $900 billion per year. Combined, over $1.5 trillion in annual revenue. That revenue depends on one fact. Those materials wear out. Concrete buildings need major repairs in 50 to 75 years. Steel structures need constant maintenance and eventual replacement. This creates perpetual cycles of demolition and rebuilding. Every generation tears down what the previous built and starts over. That cycle employs millions, generates trillions in economic activity, feeds entire industries, from extraction to manufacturing to construction to demolition to waste management. Now imagine a building material that lasts 600 years, needs almost no maintenance, does not require replacement, just sits there doing its job for centuries. What happens to the demolition industry? What happens to the replacement cycle? What happens to concrete manufacturers when nobody needs new concrete because old buildings still stand? The construction industry as currently structured cannot survive materials that last forever. The entire economic model collapses. That is exactly why hempcrete will never be promoted by people who control building codes. But here is what they did not account for. The economics work for people who actually live in the buildings. A hempcrete home costs roughly the same to build as conventional, sometimes slightly more upfront. sometimes less depending on local materials and labor. Initial investment is comparable, but lifetime costs are not even close. Conventional homes require new roofs every 20 to 30 years, new siding every 20 to 40 years, HVAC replacement every 15 to 20 years, continuous maintenance on windows insulation, moisture barriers. Over 50 years, total cost of ownership easily doubles original construction cost. Hempcrete homes require almost none of that. Walls do not degrade. Material regulates humidity naturally, so no moisture issues. Insulation is integral, so never needs replacement. Structure does not shift or crack, so finishes last longer. Heating and cooling costs 50 to 70% lower due to superior thermal performance. A French study tracked total cost of ownership for hempcrete homes over 25 years, compared to conventional construction. Hempcrete homes had 60% lower energy costs and 80% lower maintenance costs. By year 15, hempcrete homes already saved more than any additional upfront cost. By year 25, hempcrete homes saved owners tens of thousands of euros. And hempcrete homes were still perfect condition, while conventional homes showed significant wear-facing major renovation costs. For individual homeowners, hempcrete is obvious. Lower lifetime costs, better performance, healthier environment, higher resale value because the building outlasts mortgages by centuries. But for the construction industry, it is a nightmare. They do not make money on lifetime value. They make money on replacement cycles. Here is what makes this even more insane. The climate angle. The concrete industry produces 8% of global CO2 emissions. 8%. One of the single largest contributors to climate change on Earth. Making Portland cement requires heating limestone to 1400 degrees Celsius in massive kilns fueled by coal or gas that releases enormous carbon both from fuel and from chemical breakdown of limestone itself. Steel production accounts for another 7 to 9% of global emissions. Construction industry as a whole is responsible for nearly 40% of all carbon emissions worldwide. And there's a building material that is carbon negative, stronger than concrete, fireproof, earthquake resistant, proven to last over 600 years. But you cannot use it because building codes written by concrete and steel industry say so. Hemp absorbs CO2 during growth. 1 cubic meter of hempcrete sequesters approximately 110 kilograms of CO2. A typical single-family home built with hempcrete walls can sequester 15 to 20 tons of carbon dioxide. The house becomes a carbon sink, opposite of conventional buildings which generate massive emissions during construction. Hemp grows in 4 months, planted in spring, harvest late summer, reaches 15 to 20 feet in 120 days. No tree matches that. And unlike trees requiring decades to mature and heavy machinery to harvest hemp, is annual crop processed with simple equipment. University of Bath conducted comprehensive testing on hempcrete compared to conventional materials. Found hempcrete had superior thermal performance, better moisture management, and lower embodied energy than standard insulated wall systems. Embodied energy is total energy required to produce material from extraction through manufacturing to installation. Hempcrete has one of lowest embodied energy values of any construction material on Earth. Lower than concrete, lower than steel, lower than brick, lower than industrial lumber. French National Institute of Applied Sciences tested hempcrete for seismic performance, built wall sections, subjected them to simulated earthquake forces. Hempcrete walls absorbed energy and flexed without cracking. Conventional concrete walls under same stress developed fractures and structural damage. Fire testing by multiple European labs confirmed hempcrete classified as non-combustible, meets or exceeds fire resistance of concrete and brick. Structures built with hempcrete survived real fires that burned neighboring buildings to ground. Long-term study in France monitoring hempcrete buildings from 1990s. After 30 years, walls show no degradation. Material continued hardening through carbonation. Thermal performance remained constant. Buildings require almost no maintenance. Compare that to modern construction. Average American home requires significant maintenance or renovation every 15 to 20 years. Roofs replaced, siding replaced, insulation degrades. Moisture barriers fail. Conventional buildings designed to fall apart so you keep spending. Hempcrete buildings do not fall apart. They get stronger, and that terrifies the industry. Medieval bridges built with hemp still standing after 600 years. Modern concrete highways crumbling after 50. Science is published. Buildings exist. Performance data undeniable. Yet material remains illegal or heavily restricted in most developed world. This is not about whether hempcrete works. It works. Not about safety. It is fireproof and earthquake resistant, not about affordability. Lifetime costs lower than conventional construction. This is about an industry protecting itself, an industry worth over $1 trillion per year, an industry depending on materials failing so they can sell replacements, an industry that wrote building codes and control standards and makes sure alternatives never get approved. But cracks in that system are showing. Every concrete bridge that fails, every building condemned after 50 years, every climate report showing construction produces 40% of global emissions, every failure makes it harder to justify why we're not using materials that work better. France has 20,000 hempcrete buildings. UK has thousands. Canada building more every year. These are not experiments. These are homes, schools, businesses, real buildings occupied by real people who sleep better, breathe cleaner air, pay lower energy bills, and live in structures that will stand when their great-great-grandchildren are old. United States legalized hemp cultivation in 2018. That door is open. What comes next is building codes, and codes change when enough people demand it, when enough builders push, when enough architects design with it, when enough homeowners learn there is an option better than materials they have been sold their entire lives. Hemp grows in 4 months. 1 acre produces enough material to build a small house. Plant absorbs carbon while growing. Material continues absorbing carbon for decades after construction. Hemp building is carbon negative from day one. Compare that to concrete building, massive emissions from cement production, steel production, transportation, construction. Then, 50 years later, tear it down and do it again, generating another round of emissions, forever. We are living in a world where climate is changing, resources becoming scarce, economic instability increasing, and we are building structures designed to fail and be replaced every 50 years, using materials generating 8% of global carbon emissions, when we could be building structures lasting 600 years, using material that removes carbon from atmosphere, material that grows in 4 months, material tested by time and proven by science. But you cannot use it because people who wrote building codes profit from materials that fail, unless enough people learn truth, unless enough people start asking why medieval bridges outlast modern highways, unless enough people demand access to materials that actually work. The bridges are still standing, been standing 600 years. Will stand 600 more. They are proof we already knew how to build things that last. We just chose to forget, because forgetting was profitable. Maybe it is time to remember. Drop hempcrete in the comments if you made it to the end. Share this with someone building or renovating. Hit subscribe because the next video exposes a food NASA chose for space that grows in your driveway and you call it a weed. I will see you in the next one.